Hello everyone, so welcome to this new video and in this video we are gonna be trying to fill up these metrics in here in this table here. And as you can see, we have been using Attentive FP as our model and we use the default parameters and we did the hyperparameter tuning as well. And 75 epochs is the standard that we are gonna be using throughout. So what we are gonna do is we are gonna be filling up this table with all these values. So in the previous video we saw the cross validation R2 score for our default parameter was 0.565. so let's put it in here, 0.565. And what we are gonna do now is run the cross validation again with the tune parameters and for 75 epochs. So I am on a Google Colab notebook where we ran cross validation. As you can see, these are the default parameters here. And what we want is we want to replace these parameters with the tune parameters. So what I'm gonna do is just paste these parameters here, the tune parameters, and comment out the previous model and optimizer. We want to change the batch size as well from 32 to 96. So let's run all of this again. So it has started running, and as you can see, for fault 0 it has started printing out the train and test losses. So let it finish and I will get back to you with the results. So it has finished cross validating, and as you can see, the R2 score for the first fault is 0.69 or 0.680, just as a round figure. Second one 0.635, third one 0.685, and then 0.46456, and in the last one 0.677, and the average is 0.626. so this is pretty good. Initially we had 0.565. so these are the models that we can save for reproducibility. So let's fill it in here, the value for cross validation R2 score with the tune parameter, which is 0.626. Now we want to fill up these entries. We want to have train and test R2 scores for the default parameters with 75 epochs for the training. So this is the Google Colab notebook where we ran the model training, and down here you can see this is how we generated the graph data. This is the graph list where we have all our graph data. This is training and test splitting, and train loader, test loader. So I have talked about this, all of these in my previous videos. Batch size is 32 for default parameters, and these are the default parameters for the model and for the optimizer. Train test functions. Now initially we ran for 50 epochs and we had a test loss of 0.7137. the R2 score was 0.631, and for the train it was 0.768. so let's run it for 75 epochs now, just to be consistent. So let's run it. So you can see the train and test losses here. So it will take some time, and when it's finished then we can analyze the results. So it has finished running, and the test loss is 0.676, and this is the plot of root mean square error versus number of epochs, and as you can see, with increase in the number of epochs we saw a decrease in the train and test losses. So now let's evaluate. Test R2 score is 0.6697 or just round figure of 0.670, and the root mean square error for the test set is 0.676, which is same as above here. For train, R2 score is 0.837. We do wanna save this model, so I'm saving it as model underscore lipo underscore untuned with .pth extension, and you can see that saved over here. So let's fill up these values for the default parameters. For the train R2 score, as we can see, the score is R2 score is 0.837, and for test it is 0.670, and test root mean square error is 0.676. And now we are gonna be doing this again for tune parameters. Now these are the tune parameters which we wanna use now. So what I'm gonna do is go up here and you can see the batch size is 96. So let's change the batch size to 96. I'm just copying and pasting. And let's change the other parameters. So number of layers 6 and dropout is 0. Let's change the weight, decay and learning rate as well. So let me just copy and paste. Same for learning rate. So let's run these now and start training. So it has started running. So let's just wait for it to finish. So it has finished running, and you can see the test loss is 0.663 and test R2 is 0.6817 or 0.682, which is better than the untuned one. Root mean square error is 0.663 and train R2 score is 0.82. So it has come down. So basically there is less overfitting now. So it's a better result. Again, this is the test train root mean square error, but we don't need it. Of course, we want to save this model. These are the saved models here, and of course we do want to download it on our computer just in case we need to reproduce these once again. So yeah, let's just put these numbers in our table. So we have our values with us. The train R2 score is 0.820 and test R2 score is 0.682 and test root mean square error is 0.663. Now as you can see here, compared to default parameters, the values for tuned parameters is little improved. The cross validation is high, score is high, the train score is less, so that means there is less overfitting. The test R score is little higher, 0.682 compared to 0.670, and again the test root mean square error is lower. And just again to give you a comparison, I am taking you to Molecule Net Reference, which is a benchmark for molecular machine learning, and as I showed you before, for lipophilicity, the metric benchmark metric is root mean square error, and for XGBoost this root mean square error is 0.799, and for graph convolution this is 0.655, and what we have got is 0.663. so it is pretty close to the benchmark value. So I'm pretty sure if you run it for more epochs, you can get a better score at it. So yeah, that is it for this video, and in the next video we will do some post hoc analysis. So stay tuned. Thank you for watching.